Welcome, future doctors and physicists, to another exciting lecture. Today, we're going to break down one of the most fundamental concepts in physics, displacement. If you've ever wondered how physics explains your movements or why distance and displacement are different, you're in the right place. Stick around, because I'll not only simplify displacement, but also share an easy-to-understand story and real-life applications. Let's dive in. First things first, what exactly is displacement? Displacement is a vector quantity that tells us how far an object is from its starting point in a straight line and in a specific direction. It's different from distance, which only measures the total path traveled, no matter how twisty or roundabout the journey is. Here's a simple example. Imagine you're walking in a park. You walk 5 meters north, then turn around and walk 5 meters south. The distance you covered is 10 meters, but your displacement is 0 because you ended up back at your starting point. Displacement only cares about where you start and where you finish. Now here's something really important. Displacement is a vector quantity. That means it has two things: magnitude, how far the object moved in a straight line, and direction, which way the object moved. Let's imagine you walk 10 meters east. Your displacement is 10 meters east. But if you walk 10 meters west, your displacement is minus 10 meters east, or simply 10 meters west. The direction matters. Let's make this concept a bit more fun with a story about Sam, who loves exploring his town. One day, Sam walks 10 meters north to a park gate. Then, he decides to explore 10 meters east to check out a pond. At this point, Sam's movements form a right-angled triangle. Now, how far is Sam from his starting point in a straight line? That's his displacement. To calculate it, we use the Pythagorean theorem. Displacement equals square root 10 superscript 2 plus 10 superscript 2. Displacement equals square root 200. Displacement is almost equal to 14.14 meters. So, even though Sam walked a total of 20 meters, 10 meters north and 10 meters east, his displacement is about 14.14 meters in a straight line. Let's look at some real-life situations where displacement matters. For example, in navigation, a plane flying from city A to city B has a displacement equal to the straight line distance between the cities, even though its flight path might curve to avoid bad weather or air traffic. In sports, displacement plays a key role in measuring performance. A runner might complete a 400-meter race on a circular track, but their displacement is 0 because they end up at the starting point. Before we wrap up, let's go over a few common mistakes students make when dealing with displacement. Thinking displacement is the same as distance. Remember, distance is the total path, while displacement only cares about the start and end points. Forgetting that displacement can be 0. For example, if you run around in a circle and return to your starting point, your displacement is 0, even though you covered a lot of distance. Ignoring direction. Displacement always has direction. It's not just a number. All right, let's quickly recap what we've learned. Displacement is a vector quantity, meaning it has magnitude and direction. It's the straight line distance from the starting point to the ending point. Displacement can be 0, even if distance isn't. To calculate displacement, you can use the Pythagorean theorem if the path forms a right triangle. And that's it for today's lecture on displacement. I hope this session made the concept crystal clear. If you found this helpful, don't forget to like, share, and subscribe for more physics lectures tailored to your mdcat preparation. For personalized guidance, feel free to contact me at 0321-742-7930. See you in the next class. Happy studying!